So now, any solution to this equation can be written as half pi plus the even multiple of pi, or the half pi plus the odd multiple of pi. So actually, it's just any multiple of pi plus the half pi. So now, the solution set S is equal to the set of X, such that X is equal to half pi plus k pi. And here k is an integer. When k takes even number, you have the half pi plus the even multiple times pi. Okay. And when k takes the odd number, you have the half pi plus the odd multiple of pi. So actually, this general form just covers these two cases. So this is the solution set of this equation. Any question? Feel kind of new, right? Now let me show you one more example about this cosine function. So let's go to the page 567. Let's look at the problem 8. And this time we have the cosine x equal to root of 2 over 2. So first, we use the inverse cosine to find a specific solution to this equation. So we have the cosine inverse of root of 2 over 2. And this guy equal to what? Pi over 4, right? Pi over 4. And then, after you find this specific solution, you can find another specific solution between the 0 and the 2 pi. Let me show you on the unit circle. We know the first specific solution of the cosine x equal to root of 2 over 2 is the pi over 4. So at this point, you have the root of 2 over 2 as the x coordinate, and also root of 2 over 2 as the y coordinate. And you need to find the angle for which the cosine x is equal to root of 2 over 2, right? So actually, you can draw a perpendicular through this point. And then this perpendicular intersects the unit circle at this point. The coordinates of this point of intersection is the root of 2 over 2 negative root of 2 over 2. So that means if I draw one line through this point, then I can get another angle for which cosine is also equal to root of 2 over 2. See right now this guy, right? Then how to find this angle? We know this is pi over 4, and so is this angle, pi over 4, right? So right now for this guy, for this big one, it's equal to 2 pi minus the pi over 4. So this is 2 pi minus the pi over 4. And this is another angle between the 0 and the 2 pi for which the cosine x is equal to root of 2 over 2. So in this way, we find second specific solution to this equation, cosine x equal to root of 2 over 2. So right now, we have two specific solutions. So the first one, let me use the theta 1 for this pi over 4. And theta 2, that is equal to 2 pi minus this pi over 4, and this is equal to 7 pi over 4. Right? Actually, you look here. And this is a 7 pi over 4, right? So now, after we find this specific solutions, then we may just need to add the multiple of 2 pi to these two specific solutions to form the general solution. So the solution set S is the set of x such that x is equal to either equal to pi over 4 plus 2k pi, k is an integer, or the x is equal to 7 pi another specific solution plus 2k pi. And in this case, unlike the example 1, we cannot incorporate these two sets of the solutions into one general formula. Okay, we have to use these two formulas to express the general solutions. So this is another example. Now let's look at one more example. This is a special case. And we try to solve this equation cosine x equal to 1. Now, between the 0 and the 2 pi, so greater than or equal to 0, less than 2 pi, which angle for which the cosine is equal to 1? 0, right? But cosine is equal to -1, not equal to 1. Okay. So actually, you find the inverse cosine of the 1, then you get the 0, right? And for this one, you don't need to use the 2 pi minus 0 to get another one, because this 2 pi is bigger than 2 pi, right? Which is not, okay, greater than or equal to 0, but less than 2 pi. So that means we have only one angle between the 0 and 2 pi for which the cosine is equal to 1. Now, the solution set for this equation, okay, the general solution S is equal to the set of x, and x is equal to this specific solution 0 plus the multiple of 2 pi. So that is the 2k pi. Then you may simply write this as the set of x such that x is equal to 2k pi. So this is the solution set for this equation cosine x equal to 1. Now let's look at one more special case. Cosine x equal to -1. And in this case, let's first find the inverse cosine of -1. So we know this case is equal to pi, right? And if you use the 2 pi minus pi, you still get a pi. So that means between the 0 and the 2 pi, we have only one angle for which cosine is equal to -1. So now we just need to deal with this specific solution, and then we form the general solution. So the general solution, the solution set is equal to the set of x such that x is equal to this special solution plus the multiple of 2 pi. Now let me show you one more example. So this time is the cosine x equal to -√3/2. So first, we use the inverse cosine to find the one specific solution. So we have the inverse cosine of the negative root of 3 over 2. Tell me what is this value?